Hello dear all students. Today we are going to discuss about the basics of engineering thermodynamics part 2. In part 1 we have already discussed about the different terms used in thermodynamics, then different types of thermodynamic system, thermodynamic equilibrium, thermodynamic property and different types of thermodynamic processes. In today's session we are going to discuss about the laws of thermodynamics, important thermodynamic quantities and concept of energy, heat and work, sign convention for heat and work, state postulate, point function, path function, reversible and irreversible process and thermodynamic work. So let us discuss with the laws of thermodynamics. There are generally four laws of thermodynamics: zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. So these are the four different laws that involves in the thermodynamics. So let us discuss one by one. Zeroth law of thermodynamics. Zeroth law of thermodynamics, it deals with the thermal equilibrium and gives the concept of temperature equality. So zeroth law of thermodynamics state that when two bodies A and B are separately in thermal equilibrium with third body C, then body A, B and C in turn are in equilibrium with each other. So this is how the temperature equality is given by the zeroth law of thermodynamics. When two bodies A and B are separately in thermal equilibrium with third body C, then all these three bodies A, B and C will have the same temperature, and that is given by the zeroth law of thermodynamics. First law of thermodynamics gives the concept of law of conservation of energy principle, which state that energy can neither be created nor be destroyed, although it may be converted from one form to the other form. So let us take one example. Here in this case, the chemical energy of food is utilized to perform a particular work. When we perform this work, then certain quantity of heat is released from the body in the form of sweating. As like this, here the heat energy of a sun is utilized by a plant during the photosynthesis process, and after the use some amount of heat is released from the plant, and all these released heat is remains within the universe, and we can say that the total energy of the universe remains constant, although it may undergo the transformation from one form to the other form, and this is given by the law of conservation of energy principle. We can also say that the heat and work are mutually converted, means heat can be converted into the work, and when the work is performed by a body, then there will be a certain release of heat. So this is the first law of thermodynamics. Second law of thermodynamics gives the concept of flow of a heat from a body. So second law of thermodynamics state that heat cannot flow from a body at low temperature to the body at high temperature. Means heat always flow from hot body to a body at cold temperature. I mean heat, it will not be possible to flow the heat from a body at low temperature to a body at high temperature. So second law of thermodynamics gives more information about how thermodynamic process occurs within the system. So we can define the second law as: it is impossible for self-acting machine working in a cyclic process to transfer a heat from a body at a low temperature to a body at high temperature without any external force applied. So this is what about the second law of thermodynamics. Third law of thermodynamics gives the concept of entropy principle. So third law of thermodynamics state that the entropy of all perfectly crystalline solids may be taken as zero at absolute zero temperature. So let us see what exactly the entropy is. Entropy is nothing but the measure of a randomness or disorder of the system. So highly packed substance means the highly ordered molecule of the substance will have the low entropy, whereas highly disordered molecule of the substance have the high entropy. And right, we can say that greater the randomness, greater will be the entropy. Lower will the randomness, lower will be the entropy. And this is given by the third law of thermodynamics. So this is what all about the four laws of thermodynamics. Important thermodynamic quantities. Internal energy. Internal energy is one of the important function of a thermodynamic system. Right? Every system is associated with a defined amount of energy, which is called as internal energy, and it is denoted as either E or U and measured in terms of kilojoule per kg. So internal energy can be defined as the energy associated with the random disorder motion of the molecule, right? So let us take example here. Let us consider a substance at a low temperature having a particular amount of internal energy. When there will be increase in the temperature of the substance, then the molecule of the substance will move with a higher velocity, right? In that case, the internal energy of the substance will be increases due to the increasing temperature of the body. So we can say that the internal energy of a substance depends upon various factors such as temperature, pressure, and chemical nature of the substance. Second quantity, enthalpy. Enthalpy is nothing but the total heat content within the thermodynamic system. Heat content or heat possessed by a body can be referred as the enthalpy, and it is denoted by H and measured in terms of kilojoule per kg. So enthalpy or heat content of a substance may be defined as the sum of internal energy and the product of its pressure and volume. Means here H is nothing but equal to U plus P into V. Here in the given example, you can see here is the ice and here is the water. And these are the two phase of the water. One is in the solid state and one is in the liquid state. Means the water in the solid phase will have the different enthalpy, and water in the liquid phase will have the different enthalpy. Means enthalpy is nothing but the heat content within the thermodynamic system. Entropy. Entropy, that we have already discussed entropy. It is measure of randomness or disorder of the system, and it is denoted by S and measure in terms of kilojoule per kg Kelvin. Greater the randomness, greater will be the entropy. Yes, we can say that entropy of crystalline substance is minimum. Means crystalline substance is nothing but in the form of solid. Means solid has the lower entropy, whereas the molecules in the gaseous state is highly disordered. So gas will have the maximum entropy. So the next topic is the concept of internal energy, heat and work. So let us consider the piston and cylinder arrangement having the heat source at the bottom. Right? When we supply a heat to a gas enclosed within a cylinder behind the piston, right? As soon as the heat is supplied to this gas, right, the molecule of the gas will will move with the higher velocity, right? And due to this movement of this molecule with higher velocity, the internal energy of this gas will be increases, and due to the increasing internal energy, this gas will try to push the piston in upward direction and move this piston through a particular distance and produce the work done, that is equal to W. So we can define the internal energy as the amount of energy that body has within itself due to the random motion of its molecule, and their interaction is called as internal energy. Here the heat. So heat can be defined as heat is the form of energy that is transferred from one body to the another body as a result of difference in the temperature that we have already studied in second law of thermodynamics. Heat will always flow from the body at higher temperature to the body at lower temperature. Then work done W, right? The transfer of energy from one object, the transfer of energy from this gaseous molecule will try to push this piston in upward direction. Transfer of energy from one object to another, especially in order to make the second object to move in a certain direction. Here in this case, the piston is move in upward direction, right? So this is what about the concept of internal energy, heat and work. Sign convention for the heat and work. Let us consider the system, right? When we supply the heat to the system, the heat supplied to the system always taken as positive, whereas the heat rejected from the system is taken as negative. Likewise, this the work done on the system is considered as negative, whereas the work done by the system is taken as the positive. So these are the sign convention for the heat flow and the work done by the system or done work done on the system. So this sign convention is used while solving the numerical or while solving the thermodynamic analysis of the system. State postulate, point function and path function. So let us first define the state. It is the condition of a system at any instant of a time as described or measured by its property. We can define the state of the system by a different property, right? But different properties here the system changes position from 1 to state 2 by following the two different path by path A and by path B, right? And to define the state of this system, the number of properties are required to fix the state of the system and is given by the state postulate. Here we can define the state 1 by two property, right? Here at state 1, the volume V is equal to 2 meter cube and the pressure P is equal to 10 bar, right? For state 2, volume V is equal to 5 meter cube and pressure P is equal to 2 bar, right? So this can be given by a state postulate. Then what exactly the point function and path function is? When two properties locate a point on a graph, then those properties are called as point function. Here the point is located on the PV diagram at point 1, and this one point can be related with the help of two properties, right? Pressure P is equal to 10 bar and volume V is equal to 2 meter cube, right? When two properties locate a point on a graph, then those properties are called as the point function, right? So we can say that the here the change in volume during the process A and process B, we can by integrating the process 1 to 2, here we can change in volume, we can write V2 minus V1 as delta V, and this is the exact differential. Let us see what exactly the path function is. There are certain properties which can be located on a graph by a point but given by the area on that graph. Such properties are called the path function. Means heat and work are nothing but the path function. So the work done during the process A and during the process B can be written as work done during the process 1 to 2 dW is equal to W12 which is inexact differential. Means here in this case we cannot write W2 minus W1 as like this, because this is the inexact differential and this is the exact differential. So this is what about the state postulate, point function and path function. Now let us discuss reversible process and irreversible process. Reversible process is a process that can be reversed in order to obtain the initial state of the system, whereas an irreversible process is a thermodynamic process that cannot be reversed in order to obtain the initial state of the system. Right? So this can be reversed and this cannot be reversed. This is the difference between reversible and irreversible process. Infinite changes occurs in the system when process is said to be as a reversible process, whereas a finite changes occurs in the system is here the initial state and final states are different, whereas here the initial and final state are identical. But there is an equilibrium between the initial state and the final state of the system, whereas there is no equilibrium in the initial state and final state of the system. So this is how the reversible and irreversible process are. So let us take few examples of reversible and irreversible process. In reversible process, the system and environment will return to their original state, right? So let us take few examples. Frictionless movement of the piston within a cylinder. That is the reversible process. If there will not be any friction, then the piston can be regain its original position. Electric current flow through the zero resistance is an example of reversible process. Restrained chemical reaction, mixing of two samples of the same substance at the same state are the examples of a reversible process. All naturally occurring process proceed in one direction only, and such spontaneous one-way process are irreversible process. Yes, we can say that all natural process are irreversible process. So movement with the friction, electric current flow with a non-zero resistance, spontaneous chemical reaction, mixing of matter of different composition or state are the example of irreversible process. So this is the difference between a reversible process and irreversible process. Thermodynamic work, or it is often termed as PDV work. So let us consider the piston and cylinder arrangement having the gas enclosed within the cylinder, and let the piston is moving within the cylinder from state 1 to state 2. Let F be the restoring force exerted by a piston. dl is nothing but the distance moved by a piston under the action of force. Assume that the pressure and temperature of the gas is uniform and there is no friction between piston and cylinder wall. Means this is the example of reversible process. There is no friction. When the force is removed, the piston will be moved to its original state, that is state 1. Now we have to find out the work done during this process when the piston move from state 1 to state 2, and this is the example of expansion process, right? So for infinitesimal displacement, means for a very small displacement of the piston, the infinitesimal work done is there, right? Very small work is there. So work done during this process, that dW can be written as force into the displacement. F into displacement, that is equal to pressure into area into displacement, as F is nothing but equal to P into A. So by replacing the value of F as P into A into displacement, right? So area into displacement is nothing but the change in volume, right? Change in volume. So we can write the work done during the process from state 1 to 2 W12 as integration with respect to V1 to V2 P dV. So this is how we can find out the work done during any thermodynamic process. So there are the different thermodynamic process means the work done during the constant pressure process, work done during the constant volume process, work done during the adiabatic process, work done during the constant temperature process, or work done during the polytropic process. So this equation can be applicable to find out the work done during the thermodynamic process. So this is so let us take one example how the thermodynamic work can be calculated. Determine the work done by the air which enters into an aerated vessel from atmosphere when the valve is open and the atmospheric pressure is 1.013 bar and 1.5 meter cube of air at atmospheric condition enter into the vessel. Now this is the one simple example to find out the thermodynamic work. Here one system is given and system is initially a closed, means final volume will be 0. As soon as this valve is open, air will enters into the system at 1.013 bar and 1.5 meter cube of air enters into the system. So let us first write the given data. P is nothing but 1.013 bar and V1 is nothing but 1.5 meter cube. As initially the system is closed, then final volume will be 0. And to find out the work done, W12, we have the relation integration of V1 to V2 PdV, and this can be written as P into V2 minus V1, as P is constant because atmospheric pressure remains constant, P is constant. So by replacing the value of P 1.01013 into 10 raised to power 5 means 1.013 bar is nothing but 1.013 into 10 raised to power 5 Newton per meter square, and by putting all these value we can get this answer, and that is equal to 151.95 kilojoule minus, means in this case as per the sign convention rule the work is done on the system, that's why here the sign comes as a negative. So this is how we can find out the thermodynamic work during the thermodynamic process. So this is what all about the basics of engineering thermodynamics. I hope we have learned about all the basic concept of the thermodynamics. I hope you have understood all the concepts related to this. Thank you for watching this video. Thank you very much.